Dear students, this is the experiment about to find out field intensity measurement of parabolic dish. As we know that we have seen many parabolic dishes on each and every residence roofs. We will be having parabolic dish to get the to receive TV signals especially. So we have seen already. So let us see now how this parabolic dish will give you maximum gain, the received gain. That is why we are using parabolic dish as a receiver, right? So instead of other antennas, parabolic dish will be acting as a very good receiver. That is what we are going to find out using this experiment, right? So here if you see, this is the block diagram. We know that for initial setup, reflex klystron supply, then a reflex klystron tube, that is oscillator or an active device, then isolator, then variable attenuator and frequency meter. This is the requirement for initial setup. And next to frequency meter, we should have a detector to find out the initial setup frequency. The initial setup frequency usually it will be in terms of X band, that is 8 to 12 gigahertz. Usually in this lab we will get more than 9, and this is the setup. After initial setup we have got around 9.6 or 9.4, in between 9.4 and 9.6 we have got. So after that, remove the detector and connect your parabolic dish to the frequency meter. It is difficult to connect parabolic dish directly to frequency meter, so that is why what we require here is there is an S band, so which can be connected to a frequency meter. The other end of the S band can be connected to a parabolic dish like this. So this is the parabolic dish. Any parabolic dish will be having certain diameter, and we require the diameter here because based on the diameter we have to find out the distance between transmitter and receiver here. Let us see, we have kept the receiver here at this place. This is at some far distance we have kept the receiver, and the receiver, this is the antenna setup which will be having this is the stand, antenna stand. So to rotate the antenna in particular direction, we will be having a knob at the back side. So how to rotate based on some angles, that angles can be measured here. If you see this angles, you can see here angles 350 degree, 0 degree, in both clockwise and anti-clockwise we can rotate this antenna to get maximum value in the CRO. From to the parabolic dish, a detector is connected. This detector should be the same detector what we have used for at the transmitter side after the frequency meter to get the initial set of frequency. Same detector we have to use. So then the detector will be connected to CRO like this. We will get some signal in the CRO. Now the question is, how to find the distance between transmitter and the receiver here is, we have to take the diameter of this and this parabolic dish. The diameter will be usually the diameter will be usually around more than 9.5 centimeters, but we have to take it from the center here. To take it from center, we have got almost 10 centimeters. We have to take diameter, but here the diameter, instead of diameter, it is, we have taken here is radius, right? The radius, the diameter will be twice the radius, so that is why twice the radius. The value we can take either the diameter, earlier how we have shown, we can take in that way, or we can take this also. So this is called as a block, low noise block here. So we can take this also. So the diameter will be equal to 2 into radius, 10 centimeters we have got, we have taken 20 here because radius is 20, diameter is 20. So now let us see here how to find out the distance. Distance equation will be equal to 2 into diameter square divided by lambda naught. What is lambda naught here? Free space wavelength. How to find free space wavelength? Lambda naught here is C by F. What is C by F? C is velocity of light, that is 3 into 10 to the power 8 meters per second, and F is frequency, operating frequency in gigahertz. How will you get the frequency? Operating frequency means the frequency what you have got from the frequency meter, about 9.4 or 9.6 gigahertz, that frequency you have to consider it as operating frequency. Already you know that. So now this is called will be equal to C by F. So C is 3 into 10 to the power 8 divided by the operating frequency we have got. So finally the value of lambda naught what we have got here is 3.076 centimeter. Now this is about lambda naught. D is equals to 2 into dia. Dia is 20 centimeters as the radius was 10 centimeters. 2 into dia square, 2 into 20 square divided by lambda naught is 3.076, that will be equal to 2.6 meters is the distance between transmitter and the receiver. How to find? Take the tape, and this is how exactly from transmitter end you have to measure 2.6 meters. This is how you can measure the 2.6 meters till the receiver. 2.6 meters, so up to here 2.6 meters we can measure here. 2.6 meters, yes. So this is the way you have to keep your antenna 2.6 meters away from the transmitter. This is the receiver. So now the distance between transmitter and receiver will be 2.6 meters. Now we require to find out for each and every rotation. Let us see here. We have to rotate in clockwise and anti-clockwise direction. So for rotating in a clockwise and anti-clockwise direction, there is a knob here backside of your antenna setup. If you see, as you are rotating, the value in CRO will be changing. The value in CRO will be changing. Either it is maximum or minimum. Like this for every from 0 degrees you have to start. So in clockwise direction 2 degrees, 4 degrees, 6 degrees, 8 degrees, like that we have to change. Even sometimes we have to change it for 0.5 degrees or even for 1 degrees. If suppose the variation is slow, then we have to, variation is huge, then you have to check it for 0.5 and 1 degrees also. Or if variation is less, then you can check it for 2 degrees, 3 degrees also. Let us start with 0.5 and 1 degrees. Like this you can rotate this knob in clockwise direction. Once if you are rotating, see here we are rotating and the value in CRO is changing as the antenna also is rotating in clockwise as well as anti-clockwise direction. So based on that you will get the value. Similarly in anti-clockwise direction also you can rotate and vary the angle here. So you will get the values, different values from minimum to maximum value in CRO. For every 1 degree or 2 degrees you have to note down the values in a tabular column. So what is the value you are getting in CRO? So this is about taking the values both in clockwise as well as anti-clockwise. See here, this is how exactly you can take. So for each and every degree, 2 degrees, 2.5, 5, 10, 20, like this you can take the values. These are the values you have got for anti-clockwise and clockwise direction. Let us see here, at some place you will be having maximum voltage. From this tabular column if you see, maximum voltage you have got here is 0.014 volts. 0.014 volts. So now in both the directions you will get some maximum voltage. Take the 3 dB value of that, or we can say maximum voltage whatever you have got divided by root 2 or into 0.707. 3 dB value you have to take. For example, you have got 0.014 volts as a maximum voltage. Divided by root 2 if you do, you will get the value as some kind of x value you will get, right? X value you will get. For that x value, what you have to do is, in both clockwise and anti-clockwise direction, that to get that 3 dB value you have to rotate. Wherever you get that 3 dB value, that is maximum divided by root 2 value, whichever angle you are getting in one direction, in clockwise direction, that is theta 1, that is the degree of theta 1. Similarly you have to do it for in anti-clockwise direction also. In anti-clockwise direction you note down, you already tabulated the value. What is the maximum value we have got in anti-clockwise direction? Maximum value of voltage in CRO divided by root 2. So wherever you get that value, suppose that value is y value, that value where you get, rotate the knob here, this knob you have to rotate till you get that maximum value divided by root 2 in anti-clockwise direction also. That you can consider it as theta 2. So now the theta 1 and theta 2 values will be like this. You will get, so in this tabular column, the theta 1 value we have got some value as 2.5 degrees and theta 2 value we have got it as 7.5 degrees. Theta 1 value is in clockwise direction, theta 2 value is in anti-clockwise direction. Finally, to find out the HPBW, that is half power beam width, theta 1 and theta 2 should be added. 2.5 plus 7.5 will be equal to 10 degrees. Convert that into radians. So once if you convert that into radians, it will be 0.1744 for this value, right? So now 0.1744 value we have got, and theta 1 is the angle at 3 dB point for clockwise direction, Theta 2 is the angle at 3 dB point for anti-clockwise direction. As I have explained, the value of directivity you have to find out. D is equals to 4 pi divided by solid angle, beam solid angle. So what is that beam solid angle will be? Beam solid angle, that is omega A, will be given as HPBW whole square. HPBW we have got as 0.1744 in radians. That if you do square, you will get the value. So finally, that D equal to 4 pi by omega A will be equal to 412.94. This is the value we have got for one of the reading. Next, the gain can be calculated, as you know that gain is equals to directivity into the efficiency. The directivity, you can take it as directivity you have got from the previous value 412.94 into efficiency is 0.64. Usually the efficiency will be in between 50 to 70%. For parabolic dish and horn antenna, we can take it as 65%, or we can consider it as 0.64 or 0.65. Anything is fine. So 0.64 we have taken here. The value will be 268.417. Now this is the value you have got which is not in dB. Convert that value into dB. So gain in dB will be equal to 10 log of G. What we have got? 10 log of 268.417. Finally, you will get the value of gain in terms of dB will be 24.28 dB. So this is the value we have got. This is nothing but the radiation intensity of parabolic dish. So the same way we have to conduct the experiment for even for horn antenna also. Only the thing is, wherever we are taking, the equations will be different. That's all. Otherwise everything is same. So that is what. So for parabolic dish, this is the value you can get. So this is about parabolic dish. Thank you.